Can you see the screen, all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Now let us do
Sir.
the numerical problem. Okay. So a particle starts from rest, moves along a straight line with constant acceleration. What? A. Here. Read the question. Anyone?
A particle starts
If
from
it
rest
acquires
and
a
moves along a straight line with constant acceleration a. If it acquires a velocity of 3 meters per second after having traveled a distance s equal to 7.5 meter, find the magnitude.
So a particle starts from rest and moves along a straight line with constant acceleration a. If it acquires a velocity of 3 meter per second after having traveled a distance of 7.5 meter, find the magnitude of the acceleration. So these are all 2 marks questions. So let us see the question here. So a particle is starting from what? Starting
rest.
from rest. Clear? So by reading the question, let us say, let us do this problem. A particle is starting from rest means what is the initial velocity?
0.
0. And it is moving along a straight line. With how much acceleration?
Zero.
Yeah, with how much acceleration?
Straight line.
With acceleration a. Clear? And how much
Yes, sir.
velocity? How much velocity it is
Yes.
acquiring?
3 meter per second.
What is
3
the
meter per
what is the distance?
7.5 meter.
Yeah, after
7.5 meters.
yeah, when it has traveled 7.5 meter, so it's the distance traveled by that particular particle is 7.5 meter. So you have to find out what is the magnitude of the acceleration. So that was the actually question. Can you all see this white screen?
Yes, sir. Yes, sir.
No. Let us see
Yes, sir.
one by one. You have already written the question. So first, what is the given data? What is the given data? Initial velocity is
0.
0. That is u. Small u is 0. What is the final
0.
velocity?
Final velocity 3 meter per second.
3 meter per second. What is the distance traveled by the particle?
7.5 meter.
7.5 meters. Okay.
7.5 meter.
So this is all about the given data. So what you are going to find out? You are going to find
Magnitude of acceleration. Yeah.
you are going to find out what is a. Okay. So let us solve. Here you see initial velocity is given, final velocity is given, displacement is given to you. You have to find out acceleration. Out of those 3 equations, which equation you are going to use?
So second.
So V equal to U plus H square.
See, V is equal to which one? S is equal to ut plus half it square. Now you see, I am writing those equations. See, V is equal to u plus at, S is equal to ut plus half at square. In these 2 equations, t time is there or not? But we don't have any. We are not given with time here.
So third.
So V square minus V plus. Yes.
Yeah.
Square minus is equal to AS.
Yes, in that way you have to find out which equation depending upon the what are the parameters that are given to you. Depending on that, you have to finalize which equation I have to use it. So we are using this equation v square minus u square is equal to 2as. So let us substitute here 3 square minus 0 square is equal to 2 into a into 7.5. So from this equation let us find out what is a. 3 square is 9, 9 minus 0, 9 divided by 2 into 7.5. Is it correct? Whatever I have written, is it correct or not?
Yes, sir.
Okay. So you don't bring calculators in the class. At least you have taken calculator or not?
0.7. 0 answer say 0.6.
Can you see the calculator, all of you?
Yes, sir.
Yes, sir.
So 9 divided by 2 into 7.5. This is the equation. So yeah, 0.6. Somebody got it. 0.6 meter per second square.
Second square.
Okay. So this is the acceleration. All of you are clear?
Yes, sir.
Let us do next one more question.
Yes, sir.
Yes, sir.
Okay. Next question. Write down. So what is the question?
A
A
bullet
bullet leaves
leaves the
the
muzzle of a gun
gun
with
Okay,
with
wait. A
velocity
bullet
750
leaves
meters.
the muzzle of a gun. Okay. Everybody has seen the gun maybe in the movies you might have seen. Clear. The from where the actually bullet comes out. Clear. Or you can say the circular portion of the front end of the gun, that is called as the muzzle of the gun. Okay. So with what velocity it is coming out?
750 meter per second.
So now let me ask you a question. When it is coming out with 750 meter per second, is it the initial velocity or final velocity?
initial.
Initial.
See carefully. See, that is why statics is much more easier than dynamics. You have to understand the question. You see, a bullet leaves the muzzle of a gun. Before firing the gun, you are placing the bullet inside the gun or not? So when you are
Yes, sir.
Yes, sir.
placing, yeah, and that particular bullet you are placing in the breech of the gun. So you should know all these words. Where you are placing the bullet? In the breech. Okay. So when you are placing the bullet, what is the initial velocity?
0.
0. So
Zero.
when you are firing, it is acquiring a velocity of how much? 750 meter per
750.
second,
750 meter
and
per second.
yes, and it is coming out of that particular gun with this velocity. So initial velocity is 0, And finally, when it is coming out of the muzzle of the gun, it is how much velocity? 750 meter per second.
750.
Now he's saying you assume, practically it is not possible, you assume that that bullet is having which acceleration?
7.
Constant acceleration. So acceleration is constant. Okay. So what do you mean by constant acceleration? Already I told you. Velocity changes equally in equal intervals of time. Velocity changes equally with equal intervals of time. Yes or no? But practically that is not possible. Okay. Now the question is, find the time occupied by the bullet. Now when you are firing the bullet, actually the bullet was there on the breech. When you are firing it, it is coming out from the muzzle of the gun. So inside it is traveling, the bullet is traveling some distance or not? That is called as the barrel of the gun. You understand, the barrel of the gun means the long pipe through which actually the bullet is traveling is called as the barrel of the gun. Got my point? So what is the length of that barrel?
750 mm.
750 mm.
750 mm. Are you getting my points, all of you?
Yes, sir.
Barrel of the
Yes,
gun.
Yes, sir.
Barrel of the gun, is it clear to you?
Yes, sir.
Now please see here. Can you see all this here?
Yes, sir.
Now here you can see the front portion. Can you see? I'm showing with the arrow mark. That is a muzzle. Clear? This is the muzzle of the gun. Can you see the picture, all of you? This is the muzzle of the gun.
Yes, sir.
Yes,
And
sir.
Yes.
here where the bullet is placed, which is called as a chamber or the breech, from here to here, this is called as the barrel. This length is how much? 750 millimeter. How much it is? 750 millimeter. So
Millimeter.
yeah, take care of those units, please. Clear? You have to change it into meter. So be careful. Shall we solve the problem?
Yes, sir.
Yes, sir.
Yes, sir. Sir.
Now again same thing. What is the given data? Given data. Initial velocity of the bullet is how much?
0. 0.
0.
0.
Because everything we are considering, we are taking into consideration, the problem is totally about the bullet, not about the gun. So initial velocity of the bullet is 0. What is the final velocity?
750.
750 meter per second.
750 meter per second. How much distance it has traveled?
750 millimeter.
750 millimeter. Change it into meter.
0.75. 0.75 meter.
0.75 meter. The question is what you have to find out? The question was the time t, the time occupied by the bullet in traveling through the gun barrel. Okay. So what you are going to find out here? You are going to find out the value of t here. Okay. So to find out the value of t, clear?
ଏ ପିଲାଙ୍କୁ ନେଇଯାଉନି ସାଙ୍ଗରେ ନଉନାହାନ୍ତି ନା ଏଇଟା ଏଇଟା ଆପଣ କରିଥିଲେ
ଏର ମୋର କୋଉଠି ଅଛି ଏବେ?
ଥିଲା କେମିଷ୍ଟ୍ରି ନେଇଯାଇଛନ୍ତି ସେ ପୂର୍ବଟା ବାଳରେ ନେଇଯାଇଥିଲେ ପୂର୍ବଟା
ଏବେ ମୁଁ ଆଡ୍ କରିପାରିବି, ତାଙ୍କର ସରିଯାଇଲା।
କ'ଣ କରିବା?
ଦୁଇଟାରେ ନେବି, ତାଙ୍କୁ କହିଦେବି।
ତ କହିଦେବି
ଦୁଇଟାରେ ତିନିଟା ନେବି, ହେଲା?
ମେସେଜ କରିବି ତମ ସେକ୍ସନ
Okay, what you have to find out?
T.
You have to
T.
find out what is t. Okay. So what is given to you here? The initial velocity, final velocity, and the distance is given to you. Clear? So what you have to do here? Anyone? which equation you are going to use?
Acceleration find करना पड़ेगा.
Yes, first acceleration. V square minus u square is equal to 2as.
2as.
So a is equal to v square minus u square by 2s. What is v square? 750 square minus 0 square by 2 into 0.75. How much you got acceleration? Anyone? Anyone has done it? How much you got?
So 375.
37.
3,75,000.
37,375,000.
Can you see the screen?
Yes, sir.
Now acceleration you got 3,75,000 meter per second square with that much of acceleration. But our main idea is to find out what is the t here. So which equation you are going to use? V is equal to,
Sir, 1 and 2 both.
yeah, V is equal to u plus at. So t is equal to how much? V minus u by a. V is how much? 750. Initial velocity is 0. Acceleration is how much? 375,000. What is the answer? Zero point 002 seconds. Is this clear?
Yes, sir.
So this is the time taken by the bullet in traveling through the gun barrel. Okay.
Yes,
Yes,
sir.
sir.
Let us do the next question. Is it? Kindly mute. Can anyone read the question?
A shape while
A
being launched
sheep
slips
while
down the
not
slide with uniform acceleration. If 10 seconds is required to traverse the first 4.8 meter, what time will be required to slide the total distance of 120 meter? With what velocity will the ship strike the water?
So here the question is a ship while being launched. All of you know, you might have seen that before the ship is into the water, the ship is being launched. How many? I think many of you have seen this launching of the ship. Many of the videos you might have seen in the form of these YouTube reels or in most of the social media. Have you seen with the yeah clear a ship before entering into the sea it is being launched. So during launching, clear it is sliding with uniform acceleration. Again, what is uniform acceleration? I told you already. Velocity is changing in equal intervals of time.
Magnitude of time.
Yeah. So how much time is required to travel first 4.8 meter? 10 seconds. So the ship is taking how many seconds to go first 4.8 meter? So 4.8 meter, after going 4.8 meter, it is not touching the water. That is sea I am talking about. Clear? So the first case is in 10 seconds, how much distance the ship is traveling? 4.8 meter. Is this clear? Now he's asking what is the time required to slide the total distance of 120 meter. So to travel 120 meter, how much time is required? He is asking. For 10 seconds, it is 4.8 meter. So how many seconds are required? How much time is required to travel a distance of 120 meter? Is this clear? And is asking with what velocity the ship will strike the water. So here these are your important data. That is for 10 seconds, how much distance it has traveled? 4.8 meter. And what is the time that is required to slide the total distance of 120 meter that is required, that you have to find out, and what is with what velocity it is striking the water, that also you have to find it out. Have you understood the question, all of you?
Yes, sir.
Okay, so there are two cases here. Okay, now what is the given data? Yeah, the ship is being launched. When it is being launched, what is the initial velocity?
Zero.
Initial velocity, yeah, 0. Initial velocity is 0. Okay. Now, the question is, in the question it is given, when T1, we are taking T1 into consideration, when T1 is 10 seconds, when T1 is 10 seconds, what is S1? Have you written the question or should I show you the question? When T1 is 10 seconds, how much has the ship has traveled? How much distance?
120. Sorry, 4.7.
1 meter.
It is 4.8 meter.
8 meter.
Okay, so 4.8 meter. Okay, now in the second case, when S2 is 120 meter, how much? When S2 is how much? 120 meter. So the ship is, you see, what time will be required to slide a total distance of 120 meter? Okay, when S2 is 120 meter, you have to find out what is T2 and you have to find out what is the velocity. Did you get my point? What is the velocity with which it will strike the water? These are the two parameters which you have to find it out. All of you are clear?
Yes, sir.
The question is
Yes,
clear?
sir.
Yeah.
Yes, sir.
Now here which equation you are going to use? S is equal to ut plus half at square.
80 square.
Okay. So let us use this particular data in this equation first. Now what is S here?
4.8.
4.8. We are using this particular first line. Okay. When initial velocity is 0, T1 is 10 seconds, S1 is 4.8 meter. And ut becomes 0 or not, because initial velocity is 0. Yes or no? I am writing directly. 4.8 is equal to half a t1 square. Is it correct?
Yes, sir.
Half a t1 square. So what is a here? A is equal to 2 into 4.8. What is t1? 10
and
square.
10 second.
Okay. So 2 into 4.8 by 10 square. How much you'll getting?
0.096.
0.096 meter per second square. Yes or no?
Yes, sir.
Next. Next, which data we are going to take similarly? Similarly, for this data, we are going to take the same equation. S is equal to ut plus half at square. Now, what is S here in the second case?
120.
120 meter. What will be the initial velocity? Same, na? Because the same ship is traveling. Clear? The initial value 0, so this part has become 0. So half, yeah, a into t2 square. Understood? All of you? Understood or not?
Yes, sir.
So T2 is equal to, can I write here? I'm writing directly T2 into 120 by A. Is it correct?
Yes, sir.
Yes, sir.
What is A? Somewhere in the question it is mentioned, you see. It is sliding with what acceleration?
Uniform second.
Uniform acceleration. So whatever A you have found out in the first, the same A will be there here also. Got my point? So how those words are very important. 2 into 120 by 0.096. So you'll get T2 here. T2 is how much? Please find out.
15.81. 15.81.
Do it correctly.
One second.
Sir, 50. Sir, 50.
Yeah, 2 into 120 divided by 0.096.
50,
Yeah,
50 second.
yeah, 2500 root hour. Is it? How much you got? 50.
50.
Okay. So this much time it is taking for traveling 120 meter. Understood? Next, with what velocity it is
Yes, sir.
going? With what velocity it is going to strike the water? Which formula? V is equal to U plus AT. So initial velocity is 0, acceleration is 0.096 into how much? Into 50.
50.
Okay. So what is the answer?
4.8.
You got 4.8
Meter per second.
meter per second. So with this velocity, it is striking the water. So you have found out what is T2 and you have found out what is V. Or you can say V2 also, this one. Okay.
Yes, sir.
Yes.
Next is you do these two problems. Clear? I'm going to give you an assignment here
Yes, sir.
and try to do this problem and I'll share you the answer maybe in the evening. Okay. Please
Yes, sir.
take down the question, all of you, or you can take a screenshot also. It's up to you. The question is clear.
Yes.
The question is, a stone is dropped into a well and falls vertically with constant acceleration. So G is equal to how much? It is dropped. Okay. So whenever you're dropping a stone into a well, all of you know what is a well?
Yes, sir.
Okay. When you're dropping into a well, that stone is falling vertically downward. All of you are clear? And with constant acceleration, that is G is equal to 9.81 meter per second square. Clear? So when it is falling, when I told you in the
Yes.
class, when it is simply dropping, acceleration due to gravity is plus G or not? So that is plus G, 9.81 meter per second. All of you are clear? Now when you are dropping the stone, that stone is hitting the water inside the well or not, which is in the bottom of the well. So that sound of
Yes, sir.
that sound when the stone touches the water, that sound is heard 6.5 seconds after it is dropped. Can you say the total? Question is very easy. Everything is there in this statement only. What do you understand by this statement? You are in near the well. You are dropping the stone. The sound is heard into your ears after 6.5 seconds when the stone is dropped. Now you see the question is, when you are dropping the stone is traveling and hitting the water or not? First case
Yes.
is the stone is dropped and it is hitting the water. Is this clear? Assume that
Yes, sir.
assume that time taken by the stone to go and touch the water. After touching only the sound will be heard or not? When it is touching the
Yes.
water, you assume that it is T1 seconds. How much time? T1 seconds.
T1.
Okay. Now when it hits the water, now who is traveling? When the stone is hitting the water, who is traveling? The stone is traveling or the sound is traveling? When the stone touches the
So one is
water,
done.
stone will go inside the water. But something is heard into your ears.
Yes,
What is
sir.
that? Sound.
Yes, sir.
Yeah. When that particular stone touches the water, the sound is traveling to your ears. It takes some time or not? That is T2. So T1 plus T2 is 6.5 seconds. Now you understood? Dropping the stone,
Yes, sir.
it takes time from dropping the stone to hitting the water. That is T1. After hitting the water, sound travels into T2 seconds to reach your ears. So the equation will be T1 plus T2. So T1 is what? Time taken by the stone into the well. T2 is what? Time taken by the
Yes, sir.
sound. Time taken by the sound to be heard.
To reach the year.
To be heard. So T1 plus T2 is how much? 6.5 seconds.
6.5 seconds.
So if you understand this, you can easily find out what is the depth of the well. How deep is the well means the depth of the well. Sometimes in the examination, velocity of sound will not be given to you, so you should remember this. Velocity of the sound, 336 meter per second. And you all already know that sound travels with which velocity? Uniform velocity. Sound travels with which velocity?
Uniform velocity.
Uniform velocity. All of you know this, that particular concept also you are going to use. When it is moving with uniform velocity, what is acceleration for sound?
Acceleration is constant.
Zero, na? Uniform velocity means acceleration is zero or not? You have written in the starting of the class.
Yes, sir.
Uniform velocity means no acceleration. Acceleration is zero. So this concept we are going to use it. So we have time of 7 minutes. I'm thinking that let us solve this problem. Okay. The question is clear to you? All of you?
Yes,
Yes, sir.
sir.
Yes, sir.
Can you see the screen?
Yes, sir.
Yes, sir.
Okay. What is the given data first? What is the given data? Let us write velocity of the sound. Velocity of the sound is how much? What is the velocity of the sound? 336
336.
meter per second. Let us take this as V. Okay. Let S. What is S? This is what you have to find out. Let S be the depth of the whom? Depth of the well.
Well,
That is what you are going to find it out here. Very, very important question. Now let us take what is T1 and what is T2. Okay, you can take T1. Okay, you can interchange also. Don't worry. Not necessary. Whatever I am taking T1, that same thing you have to write. What is T1? Time taken by the stone. This is
to
important.
reach the well.
Yeah, time
To
taken by
that,
the stone into the well. Okay, understood. What is T2?
time taken by the sound to reach
Yeah,
the we hear.
time taken by the sound to be heard. To be heard. Any doubts? What is T1 and T2?
No, sir.
Okay. So, what is T?
T1 plus T2.
Yeah, T is the total time.
Yes,
T1
sir.
plus T2. That means when you are dropping the stone, you are hearing the sound after 6.5 seconds. So, T1 plus T2 is equal to 6.5 seconds. Any doubts here? This is very
Yes.
important. Clear? T1 plus T2 is 6.5 seconds. So
Yes, sir.
based on this only we are going to solve the problem. Okay. Now let us do one by one. What is the initial velocity? First line. What is the first line of the question? A stone is dropped. You can see a stone is dropped. Dropped means what is the initial velocity?
0.
0.
Zero.
Yeah. Initial velocity of the stone. Can you see here? Initial velocity of the stone is 0. You know the equation, all of you. S is equal to ut plus half
About square.
at
BT
square.
square.
Yeah, instead of a, you have to write gt square because motion is under gravity or not. Clear?
Yes, sir.
Yes, sir.
So initial velocity is 0. So this becomes 0. I'm not going to write. Clear? Don't waste your time also. So s is equal to how much? Half into 9.81 into what is t here?
T1.
T1 square. Very good. So it is a T1 square. Clear? So
Yes, sir.
from this
Yes, sir.
I need what is T1 to put in this particular equation. Let us take this as equation 1. So what is T1 here? Can I write 2 into S by 9.81 root over? Can I write it?
Yes, sir.
Yes. So this is the important equation. T1 is equal to root over of 2S by 9.81. Okay. Next, this is about stone. Next about what? Next come for sound.
Sound.
Next come for sound. You know, sound travels with which velocity?
Uniform velocity.
Uniform velocity. We should write this statement. If sound travels with uniform velocity, can I write the equation is S is equal to ut plus half gt square. When it is uniform velocity, this total portion becomes 0 or not? Because acceleration is 0. Yes or no?
Yes, sir.
Yes, sir.
So
Yes, sir.
equation is S is equal to U into T. So instead of U is what? We are talking about sound or not? So initially for sound, what velocity we have taken, you see here, the first line. V or not?
360.
V. So V into T2. Understood? Because for sound we have taken T2.
Yes, sir.
Yes, sir.
Clear? So T2 is equal to S by V. Is it correct?
सर सर ये बुझी पाऊँ सर यहाँ पे समझ नहीं आ रहा है
Which one?
अरे S is equal to VT2
Yeah, this how na? See, at uniform velocity, acceleration is 0. Uniform velocity means I'm explaining, you see, the velocity is uniform. Okay.
ये सर
Velocity is uniform. I told you already. Here you see. Here can you see? A body is said to have a uniform motion if it moves with constant velocity. Acceleration is what? 0. Suppose you're going in a bike. You're going in a bike at 40 kilometer per
0
hour. Yeah. You're going in a bike for 40 kilometer per hour. I'm saying that you are going in a bike from here to your home. Okay. So you see the speedometer. It should be exactly 40 kilometer from here to your house. It should be 40 kilometer per hour. That means you're not at all using accelerator or not. That is called uniform. That is called uniform motion, uniform velocity. So there you are not at all accelerating. Clear? When you are accelerating, velocity will increase or not? So uniform
yes
motion means acceleration is 0. That is why this part has become 0. Half 80 square, na? Understood?
yes sir
So S is equal to ut. U is nothing but velocity of the sound. That is V I have taken. In the given data you can see. So T2 is equal to S by V. So this equation of T1 and T2 we are going to use here. What is T1 plus T2? 6.5 seconds, na?
6.5.
6.5.
So that is what you are substituting here. You see root over of 2s by 9.81 plus s by v is equal to 6.5. Okay. So root over of 2s by 9.81 plus s by, what is the velocity of the sound? 336 is equal to 6.5. Can you see the screen? Now here, how many unknowns are there
Yes,
here?
sir.
Yes.
Only
So
one
only
unknown.
S.
That is what S you have to find out here. Okay. I am solving
Yes, sir.
here. Just you see here I am solving. I am squaring both the sides here because root over is there. So 2s by 9.81 is equal to 6.5 minus s by 336 whole square. Is it correct?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, I am doing the calculation. You verify whether I am correct or not. So 2 by 9.81 is 0.2038 s is equal to 6.5 square. This is a minus b whole square. Okay. So 42.25 plus this one you'll get a long value 0.000088 s square. Is anybody doing it? This is something like quadratic equation or not? 0.0000088 s square, this plus this is coming around 0.2425 7s plus 42.25 is equal to 0. Understood this, all of you?
Yes, sir.
This is a quadratic equation.
Yes.
You simply put it in your scientific calculator, you'll get this much of answer. You please verify. Don't solve it like how you are
Yes,
solving it
sir.
manually. You put it in the scientific calculator, you'll get this much of answer. So the depth of the well is
174.
174.43 meters. Okay.